Status.
Bodyguard.
Commander.
Rico.
Mission.
Mission. We're going to war.
The U.S. Army's Combat Capabilities Development Command, DEVCOM, was created to drive modernization across domains with a strong focus on multi-domain operations, MDO, leveraging AI-enabled systems and collaborative autonomous platforms. DEVCOM envisions a future where semi-autonomous and fully autonomous systems, airborne, ground, maritime, operate in swarms, networked through tactical cloud infrastructure, delivering real-time intelligence, surveillance, reconnaissance, and kinetic effects with reduced human risk. Unlike traditional cruise missiles, the Barracuda 100 is built around a modular, plug-and-play architecture that enables mission-specific payload configurations. Its internal payload bay can accommodate a range of swappable modules, including EO/IR cameras, LWIR sensors, LiDAR, synthetic aperture radar, and electronic warfare packages. This flexibility allows the same airframe to operate as a strike munition, reconnaissance drone, or battlefield decoy. Its architecture also supports future payloads that may include cyber-electronic payloads or compact RF geolocation tools, giving commanders the ability to adapt it across multi-domain operations without redesigning the core vehicle. The Barracuda 100 weighs approximately 200 to 225 pounds and carries a payload of up to 30 to 35 pounds. While it can be configured for one-way strike missions like a conventional missile, what truly differentiates it as an autonomous aerial vehicle, AAV, is its ability to perform persistent ISR and loitering operations. Unlike cruise missiles, which follow pre-programmed paths to a target, Barracuda can dynamically reroute, retarget, or even abort missions mid-flight based on real-time data. It can loiter for up to 45 to 60 minutes in a designated airspace, using onboard AI to scan, classify, and share targets across a tactical network. This enables it to act as both a loitering munition and a recon drone, bridging the gap between strike weapons and persistent sensors in the battle space. Unlike legacy cruise missiles like the Tomahawk, which are more expensive, $1.5 million plus per unit, and typically single-use, the Barracuda offers low-cost, scalable deployment, estimated less than $200,000 per unit, partial reusability in some configurations, and flexibility through modular payload swappability. The same platform can conduct ISR on one sortie, then be fitted for kinetic effects on the next. In a swarm configuration, Barracuda can operate as a node in a distributed kill chain, enabling dynamic targeting with machine speed decision cycles. In 2025, Barracuda 100 has undergone multiple fire and ISR validation tests with U.S. Army units, including GPS-denied terrain trials and precision strike simulations under DEVCOM supervision. Integration with command platforms like Titan and Atlas FC is underway. Fielding is expected to accelerate in 2026, initially with select units in the Indo-Pacific and European theaters, aligned with Army Futures Command's distributed recon and effects strategy. The K2 Black Panther main battle tank was developed by Hyundai Rotem, a subsidiary of Hyundai Motor Group, in response to South Korea's strategic requirement for an indigenous armored platform. Development began in the mid-1990s, following limitations observed in foreign systems operating in Korea's mountainous and wet terrain. The K2 was intended to replace older K1 tanks and reduce reliance on imported platforms like the American M1 Abrams or German Leopard 2. The K2 weighs approximately 55 tons and is operated by a 3-person crew. It is equipped with a 120mm L55 smoothbore main gun, developed domestically and capable of firing both standard NATO ammunition and Korean-developed K276 APF-SDSD rounds. An autoloader allows for a sustained firing rate of up to 10 rounds per minute. The fire control system includes target acquisition through thermal imaging, automatic target tracking, and the ability to fire on the move. Powered initially by an MTU-MB8 83Ka501, 1,500 horsepower diesel engine, with plans for full transition to a Korean-made engine and transmission system. The K2 reaches a top road speed of 70 km per hour and a cruising range of around 450 kilometers. It features an advanced in-arm suspension unit, ISU, that allows variable ride height and incline adjustments for optimized firing positions, terrain negotiation, and reduced visibility from enemy observation points. The K2 is protected by modular composite armor and optional explosive reactive armor. For active defense, it includes soft kill systems such as laser warning receivers, radar warning receivers, and automatic smoke grenade launchers. Additionally, it is configured to support a hard kill active protection system, designed to detect and intercept incoming anti-tank munitions. The tank is also fitted with nuclear, biological, chemical protection for crew survivability in contaminated environments. In a surprise move to many, Poland signed a deal with South Korean producer for over 1,000 K2 tanks, aiming to replace its aging Soviet-era fleets with a modern, combat-ready force. The decision mainly motivated by such factors as speed of delivery, high performance, and willingness to co-produce locally under the K2PL variant. For decades, bomb disposal teams within both military and law enforcement have relied on remote-controlled robotic systems to assess and neutralize potential explosive threats. The fundamental requirement: a compact, reliable, human-operated device capable of entering hazardous zones to visually inspect, manipulate, or detonate suspected IEDs, while keeping personnel at a safe standoff distance. The demand for this technology now extends far beyond bomb disposal. Modern special forces and infantry units require real-time situational awareness before launching urban or subterranean missions. These operations call for mobile systems that can map unknown interiors, detect threats, and support mission planning without triggering alarms or compromising operator safety. Such capabilities are essential in environments like tunnel networks, collapsed buildings, and contested urban zones. Founded in Israel in 2013, Robotican specializes in autonomous robotics for defense and security applications. Its flagship product, the Rooster, is a hybrid ground-aerial reconnaissance platform designed for indoor and GPS-denied environments. It combines the flight capability of a drone with the rolling mobility of a rover, enabling it to navigate stairs, tight corridors, and complex interior layouts. Its seamless transition between flight and roll modes gives it operational flexibility rarely seen in similar systems. Rooster weighs approximately 1.6 kilogram and operates with a modular payload capacity of 300 gram. It includes a full HD day and night camera, IR and visible light illumination, and optional sensors such as a thermal camera, radiation detector, and gas/oxygen sensor. It offers 12 minutes of hover time, 30 minutes in rover mode, and 60 to 90 minutes operational endurance with standby. Its encrypted mesh communication system allows multiple units to operate cooperatively in GPS-denied zones, sharing data to coordinate movement and construct a precise 3D spatial map in real time. The system also supports AI-assisted detection of predefined objects and anomalies, such as weapons, human forms, or wiring patterns, enabling faster threat recognition during reconnaissance. Rooster has seen real-world deployment with Israeli Defense Forces, including tunnel reconnaissance missions during the 2023 conflict in Gaza. It has also been tested by the Spanish Army and multiple European NATO member states during urban warfare simulations. As of mid-2025, Robotican has supplied Rooster systems to Israel, Spain, France, Germany, and several undisclosed NATO Special Operations units. Directed Infrared Countermeasure Systems, DERCM, are designed to protect aircraft from infrared-guided missiles. They function by detecting incoming threats using missile warning sensors, then directing a high-intensity modulated laser beam at the missile's seeker to disrupt guidance. This kind of systems have been integrated into a range of military platforms, including the C-17 Globemaster, CH-47 Chinook, V-22 Osprey, and F-15. Directed infrared countermeasure technology has also been implemented in civil aviation. The Israeli national airline, El Al, deployed the C-Music system developed by Elbit Systems across its long-range commercial fleet. This system was installed as a countermeasure against shoulder-launched surface-to-air missiles during vulnerable flight phases, such as takeoff and climb-out, particularly on routes deemed high-risk. Aselsan, a defense technology company based in Turkey, has developed a range of indigenous countermeasure systems, including those intended to reduce reliance on foreign defense suppliers. One of its latest developments is the Yildirim 100 system, designed to meet operational requirements for both fixed-wing and rotary-wing platforms within the Turkish armed forces. Yildirim 100 is a modular and compact system. It includes threat detection sensors, a gimbal-based tracking units, and laser modules. The system is designed to engage multiple infrared-guided threats simultaneously. Its size and weight make it suitable for installation on light combat helicopters, UAVs, and other maneuverable platforms where space and weight constraints are critical. In the most recent fire test, Yildirim 100 successfully neutralized an incoming manpad-type threat equipped with a functioning infrared seeker. The test confirmed the system's ability to detect, track, and engage real-world missile threats under operational conditions. The system's performance met all test criteria during the evaluation phase.
If you find information in this video interesting, please like and subscribe.